In this video, we're going to talk about how C# does basic arithmetic on integers and how C# evaluates complicated arithmetic expressions. We're going to look at comparison expressions. We're going to look at a bunch of different kinds of arithmetic. I want to be clear, this is going to have a lot of math in it, and some of it's going to seem pretty fiddly. But I want to be clear about how all of this works because a lot of beginner books get this wrong in very subtle ways. So let's go to the whiteboard, and we can take a look at an expression, something like, let's say, 10 plus 20 times 4. In C#, we use the asterisk as the multiplication operator. Now, you probably remember from your grade school arithmetic, right, that you follow a rule. In my school, it was called the PEDMUS rule, right? The parentheses, exponentiation, division, multiplication, addition, subtraction rule. That said you do them in that order. You do whatever's in parentheses first, then you do any exponentiation. There's no exponentiation operation in C#. Then division, multiplication, addition, and subtraction in that order. That is not what C# does. It does something very similar to that, but there are some subtleties, right? So let's go into it, right? So in this case, C# would say we have 10, and we're going to add that to the quantity 20 times 4, which is 80, right? And that's 90. So you think, well, that seems to be following the PEDMUS rule, right? Well, what about this? What if we have 30 minus 10 plus 20 times 4? Do we actually do the addition before the subtraction? Do we say, OK, we're going to do the multiplication first. 20 times 4 is 80. And then we're going to do the addition. 10 plus 80 is 90. And then we're going to subtract that from 30. And we're going to get negative 60. No, that's not what we do. The PEDMUS rule is actually a bit of a lie, right? The PEDMUS rule is actually that you do the multiplications and divisions first in order from left to right. Then you do the additions and subtractions in order from left to right. Right? So it's also not quite correct to say that the multiplication is done first, right? The actual rule in C# is what we do is we insert parentheses and until the expression is fully parenthesized. And the way we insert parentheses is first to insert parentheses around things that have multiplications in them, like that, right? Then going left to right, insert parentheses around things that have subtractions and additions in them. So this subtraction is to the left of this addition. And now we have a fully parenthesized expression, right? So these rules are called, first, the precedence rules, right? That multiplication is higher precedence than addition and subtraction, right? And what are called the association rules, right? The association rule is that things associate to the left, right? So because subtraction and addition are of the same precedence, the association rule says the subtraction that is on the left has more precedence than the addition that is on the right. All right. So now, once we've done this, does C# say, what we need to do is we need to do the multiplication first, right? Do the 20 times 4. And then we need to, because the multiplication is higher precedence, and then we need to do the subtraction, and then we need to do the addition. That's actually not what happens. Once the expression has been fully parenthesized by the C# compiler, it just goes left to right, because that's all that it needs to do, right? It can say 30 minus 10 is 20, right? It can get the right answer there. It can say 20 times 4 is 80, and now it can add the 20 and the 80 and get 100, right? All right, so that gives you the basic idea. We're going to look at some more complicated examples later on in this video. But right now, I want to go into Visual Studio here. And first of all, verify for you that what I said is, in fact, correct, right? If we have 30 minus 10 without parentheses, and we have 20 multiplied by 4 without parentheses, and we debug into this program, so I'm just going to hit F5 here. We'll hit this breakpoint. Right? And now we can look in the locals window, and we can see that, yes, in fact, I is 100. All right, so that's good. Right? Okay, well, let's give a different value to this variable I here. Let's say that I is 23 divided by 2, right? And I should probably say what all of these operators are, right? So just to be formal about it, there are addition, subtraction, multiplication, division, and remainder operators. You might not have heard of the remainder operator, but we'll talk about it. Each of them takes 2 operands. So here we have a division of 23 by 2. So what is it going to be? Well, we've said that I is an integer, but 23 divided by 2 is not an integer. So might this be an error? Well, no, it's not an error, because if it were an error, then we would have a red squiggly under it, and we don't, right? So this must be legal. Let's actually just find out. Let's just hit go, and we'll see what value I has. I has the value of 11 here after the 23 divided by 2 is computed. OK, well, apparently it's rounding down. Let's try 23 divided by 4, right, and see what happens there. Well, now I has the value of 5. So it still seems to be rounding down, even though the correct answer, in a sense, is 5 3/4, which you might think would round to 6. It's still rounding down to 5. OK, well, now let's try another little experiment here. What if we have negative 23 divided by 4? Now this illustrates something that I have not mentioned to you before, and that is that there is a unary minus operator in C#. And the unary minus operator is different than the addition, subtraction, multiplication, division, and remainder operators in that it only takes 1 operand. And those others all take 2 operands. They are called the binary operators because they take 2 operands. The unary minus operator takes only 1 operand. And it does exactly what you'd expect, right? If the expression is 0, it stays 0. If the expression is negative, it becomes positive. If the expression is positive, it becomes negative. All right, so we can apply this unary minus operator to 23 divided by 4, right? What happens with this? Well, let's find out. All right, well, negative 23 divided by 4 is apparently negative 5. So our theory before that this is rounding down is not exactly right. It's rounding down in the sense that it's rounding towards 0, right? And so it's discarding the fractional part, essentially. And this should make sense. You would not expect 23 divided by 4 to be 5 and negative 23 divided by 4 to be negative 6. It kind of doesn't make sense that the magnitude of a quantity should change just by changing the sign, right? But this fact has some interesting consequences later on. All right, let's take a look at that remainder operator. What does that thing do? Well, let's try it and find out, right? We'll say, before we said 23 divided by 2, this time we'll say 23 remainder 2 and see what happens. Well, I is apparently 1. OK, that's interesting. Well, what if we choose 4? And now the remainder is apparently 3. All right, so what's going on here is the division operator rounds towards 0. The remainder operator gives you the remainder that was discarded, essentially, right? So when you divide 23 by 4, you get 5 with 3 left over. There's the 3 that were left over. When you divide 23 by 2, you get 11 with 1 left over. The remainder is the 1 left over. All right, so now here is an interesting question. What is negative 23 remainder when divided by 4? It's negative 3. Now, this point confuses a lot of people, right? But it all makes sense, right? We know that negative 23 divided by 4 was 5, right? So how many too big was negative 23? Well, it was negative 3 too big, right? Now, there's another justification for this, and we'll go back to the whiteboard real quick here. Basically, what we want to say is we want to say the quotient is equal to 1 operand divided by another operand, right? The remainder is equal to 1 operand percent the other operand, right? Now, if that's the quotient and that's the remainder, then clearly it should be the case that the quotient multiplied by the second operand plus the remainder should equal the first operand. This is the definition of what remainder means when we are doing integer division, right? So the fact that negative 23 remainder 4 is equal to negative 3 comes naturally out of this, right? There's no other way to do the math so that it works out unless you want to then say, well, no, if I want the remainder to always be positive, then sometimes the quotient has to change in its magnitude when you change the sign. All right, so I know that's a little bit confusing, but beginners often ask this question: why is it that when I try to figure out if a number is even, right, by checking to see what its remainder is when divided by 2, why do I sometimes get negative 1 instead of 1? And that's the reason why. So in addition to the plus and minus and times and divide operators, C# also provides comparison operators. So we can say x is less than y, x is greater than y, x is less than or equal to y. Note that it has to be less than followed by equal. You can't say equals and then less than, right? And the same is true for greater than or equal to y. Now the comparison operators that compare for equality are a little bit confusing. They are equals equals y, right? So this means x is equal to y, and the x is not equal to y is exclamation mark equals, right? Sometimes pronounced bang equals. And the reason for that, the reason why we use a double equals, is because the single equals is already taken for the assignment operator, right? It can be confusing whether or not an equality is testing for equality or creating equality through assignment. So C# solves this problem by saying, OK, double equals is for testing equality. Single equals is for assignment. Visual Basic actually does this differently. Visual Basic tries to figure out from context which you mean. And if you get it wrong, it can be very, very confusing. So just try to remember that. Now, the type system of C# almost always catches it if you make a mistake, right? So let's take a look at some examples in code. We'll go back to Visual Studio here, right? We could say I equals 23 is less than 4, right? Oh, we have a red squiggly. Well, what's going on here? Well, if we mouse over this red squiggly, it says cannot implicitly convert type bool to int. What is going on there? It also notes that it says bool int operator less than int left int right. So what it's telling you here is this less than produces a Boolean. It produces either true or false, right? It's an operator on integers. It's the less than operator. And it takes two operands, which it's going to call left and right, right? We are trying to assign this Boolean quantity to this variable, which is of type int, right? So what we really need to do is we need to say bool b is equal to 23 divided by 4, right? And now if we run this thing, sorry, 23 is less than 4. And now if we run this thing, we can see that b is false, right? 23 is not less than 4. It is greater than 4, right? Or we could say 23 is not equal to 4. If we run that, then it's become true. So let's go back to the whiteboard again, and let's take a look at an even more complicated example, right? Suppose we have 30 minus 10 plus 20 times 4 is greater than 100 minus 1, right? So how would C# deal with this? Well, we know that multiplication is higher precedence than addition and subtraction. It turns out that addition and subtraction are higher precedence than the comparison operators, right? So we begin with the highest precedence, right? So this becomes parentheses around 20 times 4, right? Then we go left to right, right? Now we have 3 operations that are of the same precedence. We have 2 minuses, 2 subtractions, and an addition. Those are all of higher precedence than the greater than, right? So we'll go left to right. So this one is on the left. This one, this plus, is even more left than this one, which is on the right. And now we're done. Now we have a fully parenthesized expression. And now once we have a fully parenthesized expression, we can simply proceed from left to right. We can say 30 minus 10 is 20. 20 times 4 is 80. 80 plus 20 is 100. And 100 minus 1 is 99. Right? So let's actually try this out and make sure that we get the same result in C# as we expected. So we'll say 30 minus 10 plus 20 times 4 is greater than 100 minus 1. All right, we'll run this program and see what we get. And sure enough, it's true. 100 is greater than 99. So summing up, we saw that C# inserts parentheses around the unary minus first, then around the multiplications and divisions and remainders, then around the additions and subtractions, then around the comparisons. And in fact, there's two levels of comparison. It is very rare to have expressions that have both less than and equals expressions in them, but it can happen in some rare cases. And in those cases, the less thans and the less thans or equals are parenthesized before the equalities and inequalities. And then once all of the parentheses are inserted, then it evaluates left to right. Now, if you want to make your code more clear, you can always insert parentheses yourself. And you can always insert parentheses that override these rules. Right? If you want to say, oh, no, I really wanted to multiply. When I said 10 plus 20 times 4, I really meant 10 plus 20 is 30 times 4 is 120. You can always insert the parentheses yourself. Right? We saw that arithmetic on integers always produces integers, even division. We saw that integer division rounds towards 0. We saw that the remainder operator can be negative, and we saw that comparison operators always produce Booleans. In our next video, we're going to do the same thing, except we're going to look at floating point arithmetic.